Do this process again. I've lined them up in a classic division style here. I'm going to start off with, again, x to the third divided by x. So that results in x squared. I'm going to put that up top, x squared, multiply down to here and here, giving me x to the third plus 2x squared. I put a parentheses around it, underline it, and subtract. That turns out to be 0. So I've got 0 after all that. Bring down the x. That's a positive x. And we start the process again. In this case, this is odd because I have a 0 now divided by the x, which results in 0. So it gives me positive 0 here. Again, I multiply down here and here, giving me 0 plus 0. Put a parentheses around it, subtract, and I get x. And I bring down my 6 plus 6. So I start with that, x divided by the original x, which is 1. So I put a positive 1 up there, multiply down, giving me x plus 2. And I subtract those, which ends up being 4. And that's my remainder. So there's my remainder of 4. So the result of this is just going to be x squared plus 1 plus 4 over x plus 2. That would be my solution. Now, what this means is that this polynomial here, this polynomial, all right, if you were to plug in x equals negative 2, replace all your x's for negative 2 into this polynomial right here, and I'm getting that negative 2 thing from this. This is x equals negative 2. If you were to put negative 2's into all these guys right here, the answer you would get is the remainder. It would end up being 4. And that's what the remainder tells you. So if this original function that I circled in blue, if you were to graph the thing, if you looked on the graph at where x equals negative 2, you would find that the y value in that case would be 4. And that's what the remainder tells you. All right, so on this page we have 3 questions that ask us to solve for x. These are also rational equations. I'm going to start the first one with the LCD method. There's a couple of different ways of doing this problem, but I'm going to start with finding common denominators between these two fractions, talking about number 25, and we'll proceed from there. The best way to approach that is to start by factoring everything. Talking about the denominators specifically, because when you look at the denominators in factored form, you can have a better idea of picking only the pieces that you actually need. This is the lowest common denominator for these two fractions, and you can see I'm making two new fractions that include both the same denominator. Now, originally, this first fraction had the x plus 2, uh, and on the top, he had, well, I'm sorry, on the bottom he had the x plus 5, but what he needs is the x minus 5. So I'm going to have to put that bit in there myself, and that's how the first fraction turns out, looking like this. The second fraction already had the x minus 1. The denominator was already what we wanted it to be, so I don't really need to do anything to modify that fraction. Now that I have the fractions set up with the common denominators, I'm going to FOIL out the first guy, giving me x squared minus 3x minus 10, and the second fraction just has the x minus 1. All of this is now over the x plus 5, x minus 5 equals 1 on that side. I just collect like terms, and at this point I'm going to cross multiply. So I've got x squared minus 2x minus 11 equals, multiplying the denominator up to the 1 gives me x plus 5, x minus 5 times 1, so nothing changes there. I can FOIL this back together now, make it x squared minus 2x minus 11 equals x squared minus 25. And now I just start to collect like terms. I'm going to subtract x squared on both sides, x squared here on this side, x squared minus this side, and those two go away. So we're down to negative 2x minus 11 equals negative 25. At that point, I'm going to add 11 to both sides. So I've got negative 2x equals negative 14. You divide by the negative 2 and you get x equals 7. So there are a couple different ways of solving these problems. What I just went through was the common denominator method, but there's another method called clearing denominators. And just for the sake of showing it to you, and you can choose which one you want, I'm going to go through that way with the same problem. I'm going to go back to 25 and redo it using a different method. Now to do this method, what I need to do is find a common denominator for the whole thing. One denominator that fits every fraction up there, including what's on the right-hand side here. In this case, it's a 1, so it's not so hard, but I need to find some common denominator that works for every fraction we see up there. So in this case, that common denominator would be x plus 5, x minus 5. And I'm going to multiply both sides of the equation by that common denominator, which looks like this. Now I'm going to distribute this to the entire equation. So I'm going to go to 1 and 2. And on the other side, it won't make much difference because it's multiplied to 1. So it'll just look like this. So I've distributed that denominator to both all the pieces of the equation. And what happens now is that I can cancel out this one and this one because the whole thing is I got x plus 5 divided by another x plus 5. On the second piece, these cancel, and so do these. And on the third piece, well, that stays the way it is. So when I clean it up, it looks like this. Now I can multiply these pieces together, so I get x squared minus 3x minus 10 plus x minus 1 equals x squared minus 25. And I'll just start to collect some like terms. And I'm pretty much back where I was before. I subtract the x squared on both sides, and they add up to 0. And I move my 11, and I have negative 2x equals negative 14, and x equals 7, just like it did last time. So two different ways to do these problems. Both ways are completely legitimate. Some people prefer one, some people prefer the other. So it's up to you. Just be careful that you understand what you're doing when you put them up there, because that when you forget what if you don't understand what it is that you're actually doing, that's where your problems come up, and you start missing some pieces and some steps and so forth. All right, so I'm going to go to this next question, which is labeled 22. It looks like we messed up the ordering system a little bit, but I think we'll get through that. I'm going to go back to this LCD method because I think that's the way that most of you guys are familiar. So let's proceed with number 22. All right, so common denominator looks like 2 parentheses d minus 2 and 2 parentheses d minus 2. I don't need a common denominator on this last fraction because I'm not adding it to anything. Just these first two are being added to each other. Now this fraction already had the 2. What he needs is the d minus 2, so let's put that up top. And there was a 1 out there if you want to see it. This fraction had the d minus 2. What he needed is the 2. So here's the 1 that was there in the first place, and this is the 2 that I'm putting in there. All right, so what we have now is basically it's d minus 2 plus 2 up top. And on the denominator we have 2 and then d minus 2. Here's our d over 16. The 2's add up to 0, so they're gone. And I've got d over 2d minus 2 equals d over 16. I'm going to go ahead and cross multiply here. I want to be very straightforward about what we're doing. So I have 16d equals 2d, d minus 2, and we're going to solve this equation. Now, there's a couple of things here you may notice. Depending on how comfortable you are at this point, you can solve this. However, what I'm trying to point out here is that I could divide both sides by d, which would cancel these two guys out. You can divide both sides by 2, making this an 8, and you can proceed from there. I'll go back in just a minute if you missed that. But in this case, I'd end up with that, and I can add the 2 to both sides and get d equals 10. That's one way to solve that. But let me go back in case you missed some of that. The other thing I can do is a more straightforward approach of just saying, okay, this is 16d. I'm going to distribute on this side here and here, giving me 2d squared minus 4d. And I start to move pieces to one side. So I'm going to subtract the 16d on this side. Oops. I meant to put a 0 there. 0 equals 2d squared minus 20d. And I'm going to do a GCF pull out there. I'm going to pull out a 2d from this. So 0 equals 2d parentheses d minus 10. And here I get two solutions. 2d equals 0, so d would equal 0. And here I get d minus 10 equals 0, so d equals 10. But you have to understand that this guy does work. Yeah, they both do work. So good thing I did that. So there you go. Now what I'm doing there is I'm just looking back at the original question and seeing whether or not either of these solutions would create a 0 in my denominator. If I did that, that would be a problem. For example, if I had gotten the answer of d equals 2, well, then I would throw that answer away. It looks like 10 doesn't seem to be a problem, and d equals 0, if I put that up there, it work. Actually, I can see it right now. It works out pretty well, and it doesn't create any zeros in the denominator. That's the thing that would jump out, hopefully. If you saw that, you'd have to throw it away. Now, again, there's a couple different ways you can solve 23. You can find a common denominator, very straightforward. You can clear the denominators, as we did earlier. Or if you're comfortable enough, I'll show you a little trick here on this one, where when I approach the problem, I can see that two of the fractions already have a common denominator. And because of that, I can rearrange the question a little bit to make it a little bit easier for myself. Now, again, if you don't see that, then just proceed with your common denominator method and it'll be fine. I can go back and do it that way as well. But just because I see that in this particular problem, I see that the two of the fractions already have an LCD, I'm just going to rearrange it a little bit and make the problem easier for myself. So this fraction, x and x minus 1, okay, it sits there. Here's my equal sign. I've got my 2 over x on this side. The other fraction, though, the 1 over x minus 1, I'm going to subtract it on both sides of the equation, and it's going to end up right here. 1 over x minus 1. Now, at this point, I have two fractions that already have the LCD, and they're on the same side of the equation. So look what I've got here. I've got x minus 1 on top, and I've got x minus 1 on the bottom equals 2 over x. Well, this whole thing's just a big 1. So I've got 1 equals 2 over x. And I can cross multiply and say x equals 2. And that was kind of easy. But we can do it the other way too, and it'll work out the same way. All right, so if that didn't occur to you, we can start this problem over again and just plow forward with a straight LCD method. The left-hand side doesn't change because we're not adding or subtracting that fraction. On the right-hand side, the LCD here is going to be x parentheses x minus 1. So I'm going to make two new fractions that both have that same denominator. And when I have them on paper, I can look at the new one and the old one, compare them, and figure out what I need to adjust. This fraction has the 2 already, but what he's going to need is the x minus 1. This fraction, the 1 was sitting there, and he just needs an x. Okay? So I distribute at this point. X minus 1 equals 2x minus 2. And then my x minus 1. And I'm just going to put this as plus x. All right, there's my numerator. And I can start to collect some like terms. So I end up with 3x minus 2 over x minus 1. And I've got my x minus 1 here and x. And now I cross multiply. All right, so when I cross multiply, I end up with the x times x gives me the x squared. Carry the x plus 1 up there. Then on this side, I've got 3x minus 2 and x minus 1. Okay, so at this point, one of the things I can do is, again, if this occurs to you, you can divide both sides by the x minus 1s, and they'll cancel out. You do just have to make a note about that and say, well, one of the solutions would have been this, and then we can check on that later because we canceled it out. But again, if that doesn't occur to you, we can, just move forward in a more straightforward way. Let's just go back on that. Okay, and we can FOIL it out right here. Okay, giving us, oh boy, x to the third. I changed the colors there. I didn't want to. Apologize. All right, anyway, x to the third minus x squared equals, this is FOIL, this is 3x squared minus 3x minus 2x plus 2. And let's start to collect some like terms. I'm going to move all the pieces to the left. To the left. I'm going to move all these pieces here. I got x to the third. This is going to be negative 4x squared. These two pieces are going to become, that's negative 5, but I'm moving it over. It's going to become positive 5x, and then minus 2 equals 0. So what I did was I moved everything to the left-hand side, subtracting and adding pieces to this side of the equation. Geez, what am I going to do with this? What happened?